Welcome to TIPS Training and Certification online training program. Today we will see the basic statistical concepts which are required as a base during the calculation of Six Sigma. What is exactly the statistics? It is a technique of interpreting the data into reliable information. It consists of data, that is facts, especially the numerical values collected together for inference and information. Second, the information. It is a knowledge communicated concerning with particular facts. Mainly, statistics is divided into two types: descriptive statistics and inferential statistics. Inferential statistics. It makes inferences about the population using data from the population. Methods of inferential statistics are hypothesis testing, ANOVA, regression, correlation, factor analysis. What is exactly the descriptive statistics? It consists of set of methods for organizing, summarizing and presenting the data in a convenient and informative way. The actual method used depends on what information we would like to extract. Methods are measure of central tendency and measure of dispersion or variation. Measure of central tendency consists of mean, mode and median. Measure of dispersion consists of range, standard deviation and variance. What are these and how to calculate we will see in our next slide. Method to estimate the central tendency. There are three ways for finding out the central tendency. These are mean, mode and median. Mean. It is average is normally signified by summation of all the values divided by number of values. Mathematically, representation is given here. Median. This is a value which has equal number of values above it and below it when arranged in ascending order. If there are two values in the middle, then you have to find the mean of these two values. Mathematical representation is given on the screen. Mode. This is a value which occurs with the highest frequency. It is possible to have more than one mode if there are more than one value which appears most. Now we will see this measure of central tendency in terms of example. Samples are collected with the value 2, 2, 3, 6, 6, 7, 8. Now first we will calculate the mean. What is mean? It is the summation of these values divided by number of values, that is equal to 4.71. Median. It is the middle number in the order, either in ascending or descending. Here, when arranged in ascending or descending, the middle value comes as 5. So, median is 5. But if there is a value 2, 2, 3, 5, 5, 7 only, then the median will be 3 plus 5 divided by 2, that is 4. Next example of mode. Here, when we determine in terms of pairs, the most offering values are 2 and 6. So, here mode are 2 in numbers. The values are of 2 and 6 respectively. Now we will see the measure of dispersion. The extent of the spread of the values from the mean is called as dispersion. The measure of dispersions are represented in following terms: range, standard deviation, variance, coefficient of variance, that is CV. Mostly, standard deviation is used commonly for the measure of dispersion. These are the formulas for measure of dispersion. Range is largest observation minus smallest observation, which is in terms of formula x max minus x mean. Formula for standard deviation is given on the screen. S is equal to square root of summation of I is equal to 1 to n bracket xi minus x bar whole square divided by n minus 1. Variance. It is a square of standard deviation. Coefficient of variation. CV is equal to standard deviation divided by mean. Now we will see the example for measure of dispersion. The samples are given same as before, that is 2, 2, 3, 6, 6, 7 and 8. Now we will calculate the range. What is the maximum value in these samples? It is 8. What is the minimum value? It is 2. So range is equal to 8 minus 2, that is 6. Now we will calculate the standard deviation by putting these values in the formula. We will get 2.47 as standard deviation. Variance. It is square of standard deviation, which comes to be 6.1428. Coefficient of variation is standard deviation divided by mean, which comes to be 0.5244. As a application point of view, it is converted into percentage, that is equal to 52.44%. Higher the coefficient of variation, higher is variation. All these concepts are mainly used in Six Sigma, namely under the tools control charts, Pareto diagram, etc. Thank you.